All right, thanks, Becca. So this is the first session in the WRI seminar series. So we'll have two more, one in January, one in February on different topics. Today's topic is centered on land and water reclamation, and it's going to feature just a few of the projects that WRI and the Northern Brownfields Assistance Center are working on. For those who don't know, the West Virginia Brownfields Assistance Center is housed at WRI, and WRI is housed at WVU. So without further ado, I'll start off with our first speaker, and we have Jason Fillhart, who is a Watershed Project Manager at WRI, and he'll be speaking about the North Portal of Roaring Creek, and that is a passive treatment project.
All right, can everybody see my screen?
Yes.
All right. Looks like you have a couple of people waiting to get in, Becca.
I'll let them in. You can go ahead and get started.
Okay. All right, so thanks everyone. This presentation is on acid mine drainage and more particularly within the Tygart River watershed. So first I'm going to give just a little background on AMD, acid mine drainage, for those of you who may not be familiar with it. And then I will go into more particular details on AMD projects in the Tygart watershed. So first, what is AMD? Acid mine drainage occurs when sulfide, pyritic minerals in rocks are exposed to oxidizing conditions. So in the background, you can see AMD from a seep in that hillside. And how do we treat it? There are three ways to treat it. One is in situ treatment, another is active treatment, and the third and final that I will talk more about later is passive treatment. In situ treatment, it's used to treat AMD before the mine daylights. Usually inject alkaline materials into the mines. You can use fly ash, sodium hydroxide, etc. And it's used in areas where subsidence is often found. Active treatment occurs on sites that have been permitted after 1977 and abandoned WVDEP special rec sites. So anything permitted after 1977 is considered post law. Anything before that is considered an AML, an abandoned mine land. This also occurs on active mine sites with permits that are open, mining companies that are treating current mine portals and mine openings. Active treatment requires operation and maintenance, which includes chemical costs and sludge management. So an example of an active treatment site would be a doser. We have three different doser systems here. One site in particular in Tygart where they use active treatment is for the Three Fork Restoration Project. And you can see some photos there with the doser and then before treatment and after treatment. A fourth kind that we're sort of going to is large scale centralized systems. There are really not that many in West Virginia yet. However, with the DIL funding, there's going to be money to support these systems. Our best example is the Muddy Creek Watershed Restoration Project in the Chief. And this was the first watershed-based NPDES permit ever issued in the country. Leading on to passive treatment. It's usually a one-time system designed to treat discharge for up to 20 years. Theoretically, it does not require operation and maintenance after installation. However, we all know that it does require some O&M. Often when you use for these systems, you use alkaline materials to raise the pH and precipitate metals. Some examples of AMD treatment systems: open limestone channels, OLCs, iron oxidation terraces, ALDs, anoxic limestone drains, wetlands, saps, limestone leach beds, and steel slide beds. So some of the projects in the Tygart watershed that I'll be discussing really came to rise through a project partnership and project partnerships, I should say, with say the Tygart Watershed Association. I think Kelly is on our call today. She's the director of Say the Tygart, the National Mineland Reclamation Center, the Watershed Improvement Branch of DEP, former and also the Division of Land Restoration, Office of Surface Mines and Reclamation, and then another partner that we have have our current project, one of our current projects on, and we'll be doing 3 more projects is Penn, Virginia, and they are the landowner for these projects. I'm going to back up. So this is the Barlow portals. I'll be talking more about the Barlow portals here in a little bit, but it's a good photo of some of the AMD emanating from portals on the side of the hill. Here's a map of the Tygart River watershed. And let's see here. Our systems like down down in here somewhere. I can't find Colton on the map, but it's I'll show you another map here in a little bit. So our current projects in the Tygart, we have Roaring Creek projects. We have WV 387 and 403, which are Mars Portals North Portals Phase 2 and Mars Portals Phase 1, the actual Mars Portals. The recently completed projects we have are the Barlow Portals passive treatment site prep. For that project, we were going to do a AMD treatment installation. However, we had landowner issues, so we had to then partner with the Division of Land Restoration. And they're going to be constructing an active system, hopefully starting here in the spring of 24. And also we have our Mars Portal passive treatment project Phase 1. So here's a shot of our the Mars Portal site. This is before treatment. As you can see, we have AMD emanating from this hillside. We already get some precipitation of metals because of a little bit of fresh water entering the site. This is a DEP Watershed Improvement Branch 319 project, and we also matched funds from OSM with their WCAP funding, and Penn, Virginia also contributed funds for the project. This project was completed in September of 22. We were also able to secure some extra funding from the 319 program to add limestone that we had originally cut out due to project costs. The treatment consists of limestone beds, settling ponds, and an aeration wheel. And the goal Phase 1 is to raise the pH and settle out the precipitated metals. So here's a map of our site. We are near Colton, West Virginia, and we have the North Portals project area, and adjacent to that is the Mars Portals, and this sort of hollow right in here is where the projects occur. Here's an aerial view of our project. So this is the raw water entering first pond. We have a little bit of grouted channel and then a settling pond. I'm sorry, back this up. This is a limestone leach bed, settling pond, another limestone leach bed, and settling pond. And there's a little bit of fresh water mixed with a little bit of AMD coming in this channel over here. And here's our effluent right over here, and this is Kittle Hollow. So you can sort of see with the orange staining, sort of the metals settling out. And then as you get down to here, you get even more settling. This will eventually start to fill in. If we had an aerial in about 5 years, a lot of these ponds would look very orange. Just a little bit of system performance. Our pre-construction pH average was around 3.4. Right now, our average is right around 6.8. The pre-treated raw water total iron is about 10 milligrams per liter, and we're now down to less than 2 on the effluent, and we're at about 3 on the raw water for the total aluminum, and we're at less than 1 on the effluent. So our schedule moving forward, we have 3 more projects scheduled in order to remediate the portals in Kittle Hollow, North Portals and Mars Portals. And we are expecting 3 more construction projects in 24, 25, and 26. Going back to the Barlow Portals project, this is a significant source of A and D that directly drains in the left fork Little Sandy. And we were able to secure funding in order to have the road constructed into where the active treatment site will be located. And again, they should be beginning that treatment, that centralized treatment system in the spring of 24. And that will treat all the upper portals that flow in the left fork Little Sandy. I believe up to 2,500 gallons per minute that they will be treating of A and D. Whereas our treatment systems in the North Portals and Mars Portals treat about 150 gallons per minute. So this is on a much larger magnitude, a much larger scale. Just a little shot here of the layout for the Barlow Portals. And then so the Barlow Portals are up here. We have some other portals that enter up in this area. And then the treatment location will be down in here. So it'll pick up all these sources up above the centralized treatment. There's the photo of where this will be located. Right now, they are, of course, there's the road going down in that they'll clear and grub that, and the water will enter. This will be the eventual active treatment site. Water will enter one side, get treated, and then the effluent will go right back in the left fork Little Sandy. So a special thanks to Martin from the DEP for his project support on this, and Kelly Flaherty from Save the Tygart for making these projects possible. Any questions?
If you have any questions, you're welcome to just put those in the chat, or we could probably have you unmute yourselves, but I saw some clapping, so great job, Jason.
Thank you. All right, I guess I will pass it off to Ray.
Yeah, well, we're switching presentations. I'll just give a quick introduction for Ray. So Ray is a economic redevelopment specialist with the Northern Brownfields Assistance Center, and today he'll be talking about brownfields redevelopment projects going on within the Tygart River watershed. And we were really excited to have both Ray and Jason speak today to bridge the gaps between our water side and our brownfield side. We're both doing so much, but we don't always get to talk about it together. So really excited to have both Ray and Jason today, and also Kelly from Save the Tygart Watershed Association, because we work with Save the Tygart for all of these projects. All right. And if you're ready, Ray, go ahead and get started.
All right, I had to figure out how to unmute myself with screen sharing. Everybody can see Grafton project sites?
Yes.
All right, and it is really cool to be part of WRI and see the variety of things that our groups do together to impact and improve our state. The West Virginia Brownfields Assistance Center works statewide in assisting folks in getting EPA grant funding to deal with industrial sites and things related to that. a unique aspect of our office is that we also have a downtown redevelopment wing, and I work primarily in that, but I also support the brownfield side of things. And today we'll we work statewide, but we're going to focus in on Grafton and just kind of the variety of things that we've been involved in the last few years. Car China site. This is just fascinating. Here is the Car China site back in the 1950s. Just a booming industrial site. The whole neighborhood grew up around it. And they produced materials like you see in these photos. And they were located just below the dam. This is the site basically today. Grafton is downriver. And there's a zoom in on kind of the site as we inherited it, right, Kelly? And the buildings were gone. It was basically declared a Superfund site at one point and if you can see this bump out along the river, unfortunately, that's a sign of our early industrial disposition, and basically broken china makes up this whole new riverbank, and it's covered with dirt, and they removed some of it, and they removed the buildings, but the site was basically left, and our office worked with Save the Tygart Watershed and the county of the Taylor County Commission to just try and bring this project into good hands. And 5 years ago, I worked with Kelly, and we got ourselves an EPA cleanup grant. And while we were doing that, here's what I keep this original in my office of this, which is kind of a beautiful little rendition of look what this site could be. There's been a lot of other renditions that have been done since, but this one just is pretty and simple, and I like that. It's part of what we do, try and help people envision what things could be, especially when this is the reality of what we're looking at these days. Remnants of building materials here and foundations in the center of this site, but also these shoulder areas that you saw in the photo, perhaps, where there could be walking trails and things right along the river. We could access the river, and there's lots of potential for that Car China site. A quick recap of our activity. We submitted in December of 2018 for a cleanup grant, and were awarded it that following year, almost to our surprise, I think. Kelly and we worked hard at it, but everybody's realistic, like, oh man, this is competitive stuff. We picked a firm and conducted site analysis. A lot of our cleanup grant was spent on additional site analysis to assure that the water wasn't being impacted, and the site, the status of the site after all it had been through. School of Design at WVU came down and we had the opportunity to have them involved, and our goal is to end up with debris removal and strategic capping. And you can see who all has been involved in this. It's been a great team effort. Kelly, do you want to just jump in here and sort of say like where we're at on this final stage of I know we got our grant extended so that we could conduct some of this, hopefully.
Well, this is a fun story. I don't know if you want to go back maybe a couple slides, Ray, to the aerial of the site. That might help. So we are 5 years into a 3-year grant, and that was partially due to COVID, but actually our most recent extension was because of the latest kind of status update on the site. Ray was pointing out some of these structures that you see here on the site. And these actually, when Ray and I 5 years ago started writing this grant, we and everybody involved in the project imagined these to be remnant foundations. And we did not know really that they were part of the original Superfund cleanup, where the EPA had come in and basically taken mounds of china and encapsulated them in concrete. So the latest little hiccup in the project really has been that one of those, well, actually both of them, the one on the left and the one on the right, are essentially failing. So our current status is that the EPA has agreed to come back in and help us work on that remediation and remove the existing toxins from the site. And so we're going through, in addition to that, we are at the end of the project, we're going through the DEP's voluntary remediation program. So hopefully at the end of all of our work on the project, we will have basically status under that program to go ahead and redevelop. We've gone through several iterations of coming up with designs for the site, and we think we're relatively close to where we want to be. And so we're in the process right now of fundraising for a community building, office for Save the Tygart, and public educational space, as well as river access. In the interim, we have recently received some funding from the Appalachian Regional Commission for a short-term kind of office solution on the site. And so we're excited about that. And if anybody has any questions about the process, I'm happy to answer them.
Very cool. These projects, you never quite know what you're going to get into when you talk about EPA cleanup and industrial site management and redevelopment. So you have to be ready for the long haul, and that's been the case here. But good folks like Kelly bring a wherewithal that helps carry these kind of things home, and it's been great to be a partner in trying to bring this site to life. And again, as you can imagine, there's a city park just right down upstream from this, right below the dam. There's a whole city down below, and so yeah, let's bring it back to life. Great job, Kelly.
Well, and I do just want to say that everybody that I had the opportunity to work with in the Brownfield Center was absolutely terrific, and could not have gotten through the process without you guys.
Thanks. Well, again, any questions, we'd be glad to field them, and been a great project. I'm going to touch on just a couple more things going on in around the city of Grafton. It just seems to be a target rich opportunity at this time. And one of the sites that in the last couple of years has come to light through our office, having an assessment grant that we've been able to deploy around our footprint, and again, especially in Grafton, was the old Atlas Glass site. So there was just lots of industry going on around Grafton, and this one was right in the city limits, kind of on the west end of the city, and again, right along the riverfront, a little bit downstream from the city in this case. But the former Atlas Glass site was contained in these parcels that are indicated here. The building has been removed. Again, that was purchased by someone who kind of bought it with the idea of recycling the building, but then things just kind of languished after that. That person unfortunately passed away in the last year, but as he told his family, he wanted to leave this site to a good use, and they conveyed it to a nonprofit that's going to help clean that site up, and then we're going to look for opportunities to work with local folks to bring this site back online. It's right near a city park over here in Fetterman. And the city owns, there's a water tower here, and the routing of Highway 50 goes through here. And there is an adjacent facility as well that we're working with the local folks to try and see if there's a way to get ownership of that. But we're going to focus right now on an EPA cleanup grant that's been submitted to assure that we deal with everything that is remaining on this site. Kind of looks like that when you get on the ground. Very fascinating and interesting, all the different things that might have gone on there. And this is what we think it might be. This is just a preliminary, folks. This is not any kind of set in stone plans, but you can see the city park here, and you could connect a walking trail that got you over here. Maybe even we could route something here, I don't know, but we have to see what we can do around that. And kayak access and just different recreational activity. This is the other property, it's old box factory, it's called, and we just need to figure out whether we can do anything with that in its current state or whether it needs to be removed and all that, but that's all part of the fun of working with these sites. So that's active. And then downtown, Unleash Tygart, Heather Hudson and Alex Renneman, they're working with what's called the Cohen Building, Cohen. It's right across from City Hall. This is a rendering of what they hope to make the Cohen Building into. And they've done serious work and tapped into serious technical assistance resources to get this building assessed and analyzed and architecturally addressed, and really hoping that they're going to be able to pull together all the financing they need. It looks good. New market tax credits, historic tax credits, everything's going to go into hopefully getting the lights on right downtown in a brand new building or redressed building. It'll be great. And finally, the iconic B&O station and Willard Hotel are owned by another nonprofit that has not been able to financially do a whole lot with them. They did things a number of years ago. The B&O station is in pretty good shape and could be brought online as a venue for a variety of activities. Again, we're just initially working to try and bring this online in some fashion, but to my mind, it could be a great little cafe, wedding venue, upstairs Airbnb, downstairs tap room. There's a lot of possibilities, and wouldn't that be great in downtown Grafton to bring this end of the city back to life, along with the Cohen Building. There's a few other things going on, the riverfront stuff. It's exciting. So that's just a sampling of the kind of things we work in. Again, be glad to entertain any questions related to the Car China site, Atlas Glass, downtown, or we can all just go have a Merry Christmas and get things done a little faster. It's up to you guys.
All right. Well, we actually do have a few questions in the chat for you, Ray.
Oh, okay. I can't see it. You go ahead and tell me what we got.
That's cool. So first question, do you buy the property first, then seek EPA funding? And what happens if the funding is unsuccessful?
All right, great questions. In order to qualify for EPA cleanup grant funding, you do have to be a quasi-governmental, governmental nonprofit or a tribe. You have to be in some state of being able to field the EPA funding. You cannot be a for-profit entity. So the Car China site had become part of the county commission, and again, the transition of a property has to have an environmental phase 1 analysis and assessment in order to qualify the site for then subsequent cleanup, so they can determine like who has been involved in this property in the past. So we got that phase 1 done so that Unleashed Tygart could take ownership of it and then field the EPA grant submission. So there's yes to having it be in ownership of an appropriate entity for cleanup funding. And if you're unsuccessful, you just look for other alternatives. You clean up your application and try and resubmit the following year. It is a time-consuming process. We were fortunate to tap into EPA cleanup funding. And these days, there's a little bit more EPA cleanup funding flowing. So we're hoping for good success in the projects that were submitted in this most recent round, and will be awarded next year.
Awesome. Thank you, Ray. And then second question. So what is your project selection criteria for the projects that you work with, Ray?
Oh, golly, we don't have a specific selection criteria in our office. We try to field all comers, and then we're just honest, like if how much time we're able to invest, or but as the year goes through and we lead up to the EPA grant submission process, we just sort of divide up the projects that have come in and then provide whatever assistance we are able to be able to carry them forward. It happened that we had a little bit of capacity, and the Car China site had been one that was on our radar for a couple of years, and so we really focused on trying to bring that one home. We're not always able to invest as much time as we did in that project, but we will bring our best in any case. For the downtown projects, again, similarly, there has to be a way forward for the project. We can't simply invest in every old building in West Virginia because we've got thousands of them. But we will kind of look for those opportunities where there's a, like Unleash Tygart, the organization was active at the Cohen building, so we were able to work with them a little. And if we can get the B&O into friendly hands, and again, the Atlas Glass property, got it into friendly hands, the owner passing away and conveying it, those are the kind of things that make these then viable.
All right, thank you so much, Ray. It looks like that's all the questions for the moment. So turning things back over to Rachel, and Ray, you can unshare your screen.
All right, so we'll be moving away from Tygart watershed specific projects now and moving more into mine reclamation. And we'll be having Jacob Morris, one of WRI's graduate student researchers, present on potential uses for abandoned mine lands. And he'll also specifically be talking about one of our current projects that he leads, researching carbon sequestration on a reclaimed mine. All right, take it away, Jacob.
All right, just want to make sure everybody can see my screen here.
It's not in presenter mode, but we can see your PowerPoint slides.
Okay, 1 second. Oops. Okay.
There we go.
All right, perfect. All right, well, my name is Jacob Morris. I am a first-year graduate student in the Energy Environments program. Right now, I'm looking at carbon sequestration and crediting feasibility on reclaimed mine lands or abandoned mine lands in the state of West Virginia, utilizing C4 plants. So getting into it, the study objectives would be to study the carbon sequestration capabilities of 10 years of plant growth, and then as well as looking at the suitability of utilizing these reclaimed mine lands as greenhouse gas mitigation opportunities, specifically with a landscape suitability analysis, and also looking at the spatial variability of the soil organic carbon on the study site and comparing that to other studies. And as you can see right here, our study site is in Upshur County. So a little background on coal mining. The reclamation of abandoned mine lands in West Virginia is obviously a very big issue. It's created over 200,000 acres of underutilized lands. And I know Jason mentioned in 1977, the pre and post SMACRA bonding laws for reclamation is kind of a mess. So it's created a pretty big liability for the state of West Virginia that needs to be cleaned up. And an opportunity presents itself on these lands as a large atmospheric carbon sink compared to previous activities where they were just destroying it and emitting a lot of carbon dioxide into the atmosphere. So we're specifically looking at C4 plants. These are interesting because they have a unique carbon fixation pathway that ensures optimal carbon sequestration, as well as it can allocate biomass and nutrients to the soil through its roots more effectively than other plants, which is pretty good for the abandoned mine lands and how they recover those lands with the soil, because it's pretty rocky and not the best soil. And they do have higher rates of photosynthesis and productivity than other plants, which is why it is an interesting plant to look into for the study. So getting into the specific C4 plants, we're looking at switchgrass and miscanthus. They do grow well on marginally reclaimed lands with minimal fertilizer. And like I said, they have a very good rooting system, which helps with the soil on mine lands. And it reduces the amount of tillage and fertilizing needed with a high tolerance to acidity, which is all variables of mine lands. So the study site is in Alton, West Virginia. It's a former bond and forfeiture site, the DLM. It has hundreds of acres of reclaimed mine lands, but the specific study is right down here in the bottom right-hand corner. where we have 6 plots of miscanthus and 6 plots of miscanthus. Originally in 2010, it was these plots were planted as a biofuel study, but now it serves as a carbon sequestration study. So the sampling methods were to get 4 samples from each corner of the plots. 144 square inches samples were taken, and then analyzed using, well, the soil sampling was analyzed using the Walkley-Black method, the low sonic emission method, and the combustion method, and then they were all averaged out. And then that was to analyze the total organic soil carbon and the nutrient levels within the soil. And then there was also a biomass package taken as well to analyze the soil nutrients and everything within the soil. And then we had samples taken at the beginning of the 2023 growing season and then at the end of the growing season for 2023. So for the data preparation methods, which is categorizing it into pre and post growing season data, biomass sampling was segregated from the soil carbon sampling data. And then it was uploaded to ArcGIS to visualize X and Y location features so we can see where the study site's at and where each sample was taken. And then that was to be used to differentiate between switchgrass and miscanthus, which brings me to the spatial correlation analysis, sorry. So what we did here was created histograms and QQ plus to kind of determine the spatial correlation and its distribution to average carbon percentages throughout the growing season. So as you can see here up at the top, this is pre-season, and then post-season, where you can see it definitely follows the bell curve and has a little bit more of an even distribution post-growing season, which I'll get into in a little bit. But then the outcomes were integrated into a soil organic carbon surface, illustrating the spatial distribution of the soil carbon, which is right here. So this was based off the biomass carbon data. So as you can see here, the blue dots, this might be a little hard to differentiate, but the blue dots would be the miscanthus up here at the top left, and then the lower right-hand corner is more so the miscanthus. So you can see here it's a little bit more evenly distributed after the growing season, and you can see that it kind of follows the bell curve. And then here are maps of the standardized errors of the analysis. So you can see that there's not a lot of errors right here up in the middle, but when you get to the outsides and the peripherals of the study area where there's not a lot of data density, you start to get a little bit more error, which just kind of confirms that you need more data points to get better data. So then moving on to the landscape suitability analysis, there was 3 criteria that was involved in this. It was climate criteria, geography criteria, and then other criteria. So for the climate criteria, it included minimum temperature and precipitation. The temperature scores had scores from 5 to 3 and had -5 degrees to -10 degrees temperatures in that range. Precipitation scored a 1 to 5 for 300 millimeters to 900 millimeters. Moving into the geography criteria, slope scored a 5 for a 3-degree flat slope to 0 and unsuitable for extremely steep, which I believe was 35 degrees or above for slope. And then moving into elevation, there were scores at 5 at 200 meters to 1 at 1400 to 1600 meters, emphasizing lower elevations are better for biomass productivity. And then the other criteria that was involved in the landscape suitability analysis was the distance to roads and distance to populated places. So distance to roads, there was a 50-meter restricted zone buffer, and populated places, there was a 100-meter distance buffer. But then as you get closer to those buffers, the suitability is higher than the farther away you get from them. And then getting into this is the maps of the geography criteria. So this is the elevation map, as well as the slope map. So you can see elevation has some pretty high suitability, except for the northeastern region of West Virginia. And then slope has a good bit of not suitable areas or unsuitable areas. Getting into the distance criteria, you can see here populated places and road suitability. It's a little harder to see for the road suitability. These gray looking areas are not suitable, and then everything else appears to be pretty suitable. And it follows the same kind of pattern for the distance to populated places where you have that buffer where you can't grow, and then as you kind of get farther and farther out, it becomes more suitable. And then right here, this is one of the limitations of the study. It was kind of hard to find good data for precipitation and minimum temperature. This was just gotten from the USGS. But this just shows precipitation right over here, and then on the right-hand side, it shows the minimum temperature maps. And then what we did with that was a weighted overlay analysis, which allowed us to take all of the different variables, overlay them with their suitability ranks to give us one suitability map. So the weights were assigned to each variable. So each category, like I mentioned earlier, the climate criteria, the geography criteria, and the other criteria, they all had different percentages with the weights of how important they were. And then these layers were overlaid and the suitability was multiplied, so we can see just exactly where the best regions to grow are in West Virginia. And then we're going to utilize these results to guide the transformation of mine lands into sustainable areas for carbon sequestration. So the conclusion is the spatial correlation analysis reveals that there are distinct pre and post season distribution patterns, with the postseason adhering to the bell curve, showing in seasonal changes, and the dynamic processes of the plant and plant growth and microbial activity influencing the carbon distribution, specifically switchgrass and miscanthus. And then the landscape suitability analysis emphasizes the impact of minimum temperature and elevation compared to some of the other variables, and provides insights for land management and sustainable energy production. And then as well as mine land reclamation potential, highlighting the potential of reclaimed mine lands for bioenergy, crop cultivation, and carbon sequestration, and then offers reduced environmental impacts and contributes to long-term energy viability. So the impacts of this study would be providing West Virginia with post-mining opportunities while transforming a former mine site into a mitigation site, creating innovation carbon reduction solutions to offset carbon dioxide from the atmosphere. And then that can lead into crediting carbon as well as biomass production as well. So the future objectives would be to identify mine lands with that suitability analysis. That would be unreclaimed abandoned mine lands. I could separate those. And then determine the acreage of all those mine lands with their distinct suitability analysis rankings. And then extrapolate the results from the specific study site to other abandoned mine lands in West Virginia, as well as adding additional variables to the landscape suitability analysis like soil data and other things that could be used, specifically with the biomass data that we got that could have some good implications. And then acknowledgements would be to the Appalachian Stewardship Foundation that gave us the funds for that, and then the Water Research Institute for the opportunity. So I guess I can take any questions now. That's all I got for now. Thank you.
Thank you so much, Jacob. We have a comment in the chat that I'm going to turn into a question. Have you ever checked out the Oregon State PRISM data for temperature and precipitation?
I have not seen that, but I will definitely check that out. That could be a big help.